Hi, myself Gogul Krishna. I will be explaining the project Inverted Search, which I have done as a part of data structure module. So, what is inverted search? An inverted index is an index data structure storing a mapping from content such as words or numbers to its location in a database file or in a document or a set of documents. So basically, in this project, we are creating a word database from a single or multiple files. Once it is created, we can manipulate the database either by adding or searching for a word. So again, we are creating a word database which will be having the contents from multiple files, and we are mapping the words from multiple files and making it as a database. We can search for particular word in the database which we have created. So the purpose of this inverted index is to allow fast full text searches at a cost of increased processing when a document is added to the database. So why inverted search? What is the advantage of using inverted search? So before going into that part, we will discuss something about forward indexing. Let us say there is two documents, document 1 and document 2 contains a list of words, and in forward indexing, the documents are mapped in such a way that each document links to the other document, and in within the documents all the words are indexed in it. So in forward indexing, it scans the document, prepare a list of unique words, and map all the words to the document as an index. Here, document 1 contains all the words given below, and document 2 contains all the words given below. It directs from documents to the word. So here, in inverted indexing, it was scans the document and prepare a list of unique words. Then prepares a list of indices of the words and map them to the document search. As it is given, the words are first indexed, and from the words the documents are mapped. Like hi is available in document 1 and document 2, hello is available in document 1, am is available in document 2. So it directs you from word to document. That is basically inverted indexing. The advantages and applications of inverted search is that it is easy to use and it is easy to develop. It is faster than forward indexing. So coming to this example, if we want to check for a word, we have to check for that word in each and every document. Since it is mapped with respect to the document, we will be checking each and every documents. If we want to search for the word good, first we have to come to document 1. We have to check all the words which is mapped in document 1. Then we will go to document 2. Then we can check at final traversal we can get the word good. But when coming to inverted index, if we want to find the word good, we can find the index first, and we can check the index. If the index contains a word, we can directly map to the document which is having that word. So in a way, it is faster than forward indexing, and also that search can be done within one traversal. Usually inverted search is used in document retrieval system and used in most of the search engines. So coming to the project overview, we are in the program we are doing 5 major functions, that is create database, display database, search database, update database, and save database. In create database, the files in which we are using to create the database is passed as input to the program as command line arguments, and after validating and reading the files, the database is creating accordingly. The second function is display database. In this function, whatever the database we have created previously, that is displayed. Then comes search database, in which the words which is mapped into the database that can be searched and the result can be seen. Here the word R is been mapped to the files, and it is in the respective database which we have searched, and we have found the result accordingly. Then comes update database. Here we have created a database using file 1 and file 2. Let us say we have to add another file, file 3. So update database function comes into picture. So this file 3 is added to the existing database and a new database is created. For that purpose, update database function is used. Then comes save database. Here the created database is saved to a .txt file for backup and future reference. So creating to the most and basic function, create database. This is a fundamental building block of inverted search. Here, as the image suggests, with the help of linked list and hashing algorithm, we are creating the database. The words with the help of hashing function is indexed to a hash table, and within that hash table the words is mapped to the respective documents. So hashing is a technique of mapping data under particular index, thus providing optimal for search. The project mainly consists of three linked lists. One is for collecting the file names from command line arguments. Then the other one the other one consists of the word node, which consists the words file count and its main link and sublink. Then comes the other linked list, which is a file node, which we can call it as file node, which consists of the word count, the file name, and link to the next node. Here you can see this is a hash table which is created with the hashing algorithm by mapping the words into its respective indexes. Here the words are mapped in a way that each word node is connected to the next word node in the same index. This is known as direct chaining. It is used to avoid the collision mechanism. This is used to avoid collision. Here from the picture, it is clear that the word apple is not only present in file 1 and it is also present in file 2. So the file node comes into picture. The hash table consists of the index of each and every word, and in each index the words are mapped accordingly by the main linked word node, and there exists a sub linked list which contains the word count and file name, in which the respective words are connected or linked to its files. This is a general overview of the project. Coming to the implementation of create database functions. First, we are getting the list of file names as command line arguments. Then we are opening files one by one. In the file opening part, we are checking for some validations. First, we have to check whether the command line arguments is passed or not. If the command line arguments is not passed, we will send an error message and we will tell the user to send the respective files accordingly. If the file is sent, we will check whether the passed file is a .txt file. After confirming that it is a .txt file, we will check whether the file exists or not. If the file does not exist, then we will return an error message. If the file exists, we will check if it is empty or not. If it is not empty, then we will check if it is a duplicate or not. If all the conditions is satisfied, then we will return success. After reading and validating the files, we are creating the database with the help of hashing algorithm, and we are mapping the words to its respective indexes. So first we will check whether the word is same as and the file is same. Let us say in this given example, we have already mapped apple to file1.txt. If there comes another occurrence of apple, first we will check whether this apple is part of this file1. If it is a part of file1, then we will just increment the file count, then we will just increment the word count in the file1 file node, in this file node. If the file is different, we can take the similar example. Here the already existing apple is again added, and we are checking if this apple is added from the same file or not. If it is not added from the same file, we are adding another file node, and the file name is saved in that file node, and the word count is incremented. So as it says, we are creating a file node, attaching it to the previous, then increment the file count. And we are checking the other condition, whether the word is different and file is same. Here, after the word apple, after some particular time, the word hi occurs, and we are checking whether this hi is from the same file or not. If it is from the same file, we are we are linking that word hi to the same file, and we are incrementing the word count. If the word is different and the file is different, we will again create a main node and file node and attach it with the pointer. That's it. Return success after the end of the program. Then comes the display database function. So display database is basically to just to display the created database. So we will run a loop from 0 to the last index. Here it is 26, since 26 alphabets are present. So up to 26 we will run a loop. We will check each indexes of the hash table whether it is present or not. If node exists, we will print the word and file count. If the word is in multiple files, then we will print the file names and the word count. Then we will increment the index, and we will continue this operation until each word index is null. Then comes the search database function. Here we will first identify the word index with the hashing algorithm. Let us say we want to we want to search apple. So with the hashing algorithm, we will find the word index which is 0. Then we will check for the word apple. If the word is found, we will print the file count and the word count. If the word is not found, then we will traverse to the next node of the word node until null is reached. If the null is reached and the word is not found, then we will return failure. Then comes update database. In update database, first of all, in update database, first we are entering the file name. So first we will add this file to the file linked list, existing file list, and we will check the recheck all the validations. That is whether the file exists or not, whether the file is empty, uh, whether the file is any duplicate or not. After all the conditions are satisfied, then we will add the file to database. So coming to the save database function. In the save database function, we are giving a file name of .txt. So we are using a file pointer. With the help of a file pointer, we are opening a file in write mode in which database has to be saved. After opening the file, we are checking whether that open file function is successful or not. If the file open function is successful, then we are running a loop from 0 to the last index of the hash table, and we will check each word node in the hash table until null. We will write the index, word, file count, file name, word count to the file name, and move to the next node until it reaches null. So here we are passing the file names as input to the program through command line arguments. So after compiling and running the program, we are first creating the database. So the database for file 1 and file 2 is created successfully. So second of all, we are displaying the database. So yes, we can see that the database which we have created is working as our requirement. So we are going to search for data. So here we will search for how. So how is found in database and is present in two files, so that is also working properly. And we are updating the database with another file. We are saving the database. So the backup file is created and the data is saved in it. We can check it in the directory. So here the updated database is saved. So that's it all about the project. So this is updated database. This was the previous database. We can see the indexes 0, 5, 7 and 24. So the indexes are updated. So database is updated. So that's it. Thank you.